Hello everyone. Let's discuss today the concept of handling imbalanced dataset. So it is said that model is as good as the dataset is. So having good dataset to have good results and good performance of the model, whichever model you choose is very much necessary. So as a step of pre-processing of the datasets, we have to handle imbalanced dataset. Let's see first what is the concept of imbalanced dataset. We have in our real life many times the many examples like I want to see whether a disease exists or say cancer exists or not. So I will have many patients without cancer and I will have very few patients with cancer. So obviously my records will be, my dataset will contain many records without cancer and very few records with cancer. Similarly, I want to see whether the transaction is fraud. So in say 10,000 or 50,000 transactions, there may be possibility of one or two fraud transactions. I want to detect whether email is spam email or not. So we receive many not spam emails and there are very few spam emails are very few in number. Similarly, if you want to say uh, detect attacks on some network, some security attacks, then very rare cases we have the records of attacks and mostly it's normal access. So in that case, whatever dataset is created, one class will have or one category will have so many records and other category will have very few records. For example, if we say the example of security attack, then there can be different types of attacks like backdoor, injection, no, password, scanning, XSS, and the middle bar is of normal access. We can see here in the graph that records with normal access are very high than the records with attack. If we give as it is input to the model, then there is very less scope to learn about the different types of attacks and model will learn more about the normal access and then there will be problem of overfitting and model will be failing to understand and give results on different type of attacks. So how to handle it? Before applying the model, we have to convert the imbalanced data set into balanced data set. To convert it into balanced data set, there are various methods available. Out of those various methods, now we will discuss three methods. Let's go one by one. Methods to handle. First method is random oversampling. Second is random undersampling and third is synthetic minority oversampling technique, popularly known as SMOOT. So let's go to first, that is random oversampling. In random oversampling, what we do is we concentrate on the categories where the number of records is less and we try to match the number with the one class where the number of records is very high. That's what we duplicate the random instances from minor class until we get it matched with the majority class. In our case, we have to increase the number of records of attack classes with the normal class. So how to do that? What we do is we take same records and we try to create duplicates of the records until we get the count as same as of that majority class. So this you can do very much by using Python, where we can import the resample function from sklearn.utils. So what inputs it is taking? It is taking the class which I want to resample. So I want to resample backdoor, which is mentioned in the variable minority class. Then replace equal to true will help me to duplicate same records. The number of samples, how many records I want the records same as count of normal, and random state initialized to some number which will help me to take same random samples in different runs of the model, and I can have the comparison of results. And once I get those samples, then I can concatenate the minority class and majority class and put it in one variable using pandas concatenate function, and I will have balanced data set. So that is what is random oversampling. Now that is one approach. So can I go other way? That is, whether can I reduce the numbers of records from majority class and make them as minority class? For example, can I reduce the records from normal class and I can make them make that as matching number to different types of attacks, security attacks? So that's possible with second method, which is random undersampling. So in random undersampling, what we are doing is we are reducing the instances from the majority class until we have balanced data set. In our class, we have to reduce the records from normal class. So that also we can do using Python, where I have to again use same resample function, where the first parameter, what I want to change now, instead of minority class I want to change the majority class. Then I don't want to have duplicate, because obviously we are reducing the number of samples. That's why replace equal to false. How many samples I want? I want the samples as same as the records with backdoor class and random state initialization, and once I run this I can concatenate them and I get the balanced data, where I will have records of backdoor and normal class same in number. The records of normal class will be same in number as that of backdoor class. That is second way. So is it fine? No. Why? If we say oversample in method, first method, in that case we are duplicating same records. So the model will get overfitted and it will only learn about same attributes or same features. What about undersampling then? In undersampling, we are removing the data that we have. So it's quite possible that we are losing the important information. Then what to do? So what we can do is we can use the next method, that is SMOT. SMOT is synthetic minority oversampling. What we are doing in that is we are generating synthetic instances of the minority class. So it's like oversampling only, but we are not creating duplicate records. Instead of that, instead of that, what we are going to do is we are creating synthetic records based on the existing data, and we can reduce the risk of overfitting. So that also you can do using the Python functions. So under imbalanced learn, that is imb learn dot oversampling, we have SMOT, import SMOT, and you can create a variable of SMOT random state equal to 42, and you have to just pass to SMOT what you want to resample. First parameter is all the feature columns, and second parameter is the column with class labels. So class labels like normal, backdoor, etc., whichever we have in that particular column will be our Y. So that is data of class label, and X will be all the columns except the column of the class label. So data.drop class label and axis 1 will give me all the columns except the class label column, and if I run this I can get the data set, which is the balanced data set, and with the records generated using the SMOT technique. So This is the sample of having the balanced data set after applying smooth. You can see that we have the same number of records for all the classes after applying smooth technique. Oh, whether it has been working say fine or not, that we can very much see using different evaluation techniques. Oh, for imbalanced data set, just looking at the accuracy won't be fine. We have to look at precision, recall, F1 score, then uh, RUC curve, which will help us to understand whether our model is doing good by applying the um, balancing